So I hope the video segment that you watched with Kirk helped you understand how to apply the laws of logs with log to some base. And it's important to remember that natural log is a logarithm. It's the log base e of x. So all of the laws of logs that apply with log also apply with natural log. It's also important to remember that all the things that we say about logs, we talked about this function at length in the very first lesson a week ago Monday, when we first started the remote instruction. We talked a lot about logs, the domain, the range. I hope you recognize that all of those same properties apply here to natural log. So if I look over at this graph, we talked about the range and domain of exponential functions and logarithmic functions. So if this is e to the x, then the domain is all reals, right? I can input all reals, but my output is only positive, right? Because no matter what I raise to a power, no matter what base I raise to some power, I output a positive. All right. Therefore, when it comes to both natural log and log of any base, my domain, right, the domain in this case is only positive numbers, 0 to infinity. Okay. And then the range would be all reals. And all logs pass through the point 1, 0 because all exponential functions pass through the point 0, 1. Okay, so all of the properties of logs that we have learned and that you learned in Kirk's video apply to natural log. So anyway, here is a list of the same laws that you saw on Kirk's video, except now they're with natural log. Okay, so if you were good at the problems on Kirk's video, you're not going to have too much trouble here. A couple other things we haven't seen though on Kirk's video, but we already know this, right? I'm going to put a check by this because we know this. Natural log of 1 is 0, right? That's, I know in calculus that will come up a lot when it comes to simplifying log expressions. Again, we know the natural log of 1 is 0 because the point 0, 1 would have to lie on the graph. And another law here is that natural log of 1 over x is the same as negative natural log of x. Again, this comes up in calculus a lot when you're simplifying expressions or when you need to recognize equivalent expressions. Let me illustrate this for you. If I had the natural log of 1/2, okay, natural log of 1 over 2, and I apply this quotient rule to it, right, where this is equal to the natural log of 1 minus the natural log of 2. So I'm applying this law right here to this. Well, what's the natural log of 1? Right, the natural log of 1 is 0. Right, so I get 0 minus the natural log of 2, which is obviously just negative natural log of 2. Okay, so that's how I can verify that last rule. So moving on to some practice exercises, if I want to rewrite this expression here in number 1 using these rules, first I'm going to apply the product rule and the quotient rule, and then second I will apply the power rule, the log of a power rule. Eventually I'm going to hope you can do all of these in one step. Okay, so starting off, I have my product rule, so that's a cubed plus natural log of radical b minus, since it's a quotient, minus natural log of c to the 7th. Okay, but then what I do, according to the power rule, is these powers come in front, right? And I should recognize, that's supposed to be an arrow in front. I should recognize that radical b is b to the 1/2. right? So the half would come out in front. So my final answer in this case is, and I'm gonna do text effects, should be easier. 3 natural log A plus a half natural log B minus 7 natural log C. Okay, so I wrote it out in 2 separate steps where I did the product and quotient rule first, and then I applied the power rule. But like I said, I hope later you can do that all in one step. All right, this exercise in number 2 asks you to match. I gave you some expressions here in A through D, and I want you to match them to the answer in 1 through 6 below. So when we were on the chapter on simplifying radicals, I had told you to memorize perfect squares and perfect cubes. So I'm hoping that you could recognize things like 27 is actually 3 cubed, right? So I could rewrite this as natural log 3 cubed. Well, then this drops in front, right? That 3 drops in front. And so I would select 3 natural log 3 to match this, okay? So powers of 10, I hope you know you just count the zeros, right, on powers of 10, and that's the power that I've raised 10 to. So please pause the video and try matching the rest of these. Okay, so there's the final answers. Okay, moving on. Write the expression as the log of a single quantity. So this time, so far we've been applying the laws to an expression. Now I'm working backwards. Here's an expression where the law of logs had been applied. Can you go backwards and say the expression that I started with? Okay, so I can tell since I'm adding these expressions that I had a product, right? The numbers in front are the exponents. And I can tell that I had a quotient because of the subtraction. Okay, so take a minute and try to decide what got multiplied, what is in the denominator of my quotient, and what are the exponents, if any, or roots. Okay, so take a minute. Okay, so I would multiply 3 by the square root of x by y. I can tell that because of the addition. And then that is divided by, so the power on z is the 1/3 power, which is the cubed root. And this would be my logarithm of a single quantity here. So on Kirk's video, we have different goals, and I probably will assign you more of Kirk's videos, but he was in his video trying to get students ready for the types of questions that are asked on Algebra 2 on the Regents exam. All right, my goal is to get you ready for calculus. And let me talk a little bit about why we need logs in calculus. When you do some of the operations in calculus, And you have to work with an expression like this. If you took the laws that you're going to learn and you tried to apply it to an expression like this, you would get a horrible nightmare of a mess. However, if you take the natural log of both sides, so when we're working with an equation, right, when we do the same thing on both sides, as long as we do that, right, then that's legal, right? That keeps the equation in balance, okay? So if I were to take the natural log of both sides, okay, and then I get the natural log of this whole thing. I'm not going to even try to write it with my poor little mouse. But anyway, if you were to break this up using the law of logs, it will be so much easier to do the operations that you have to do in calculus. All right, so this gets done all the time in Calc 1 and in Calc 2. So anyway, I have a product here, so I would apply that law where that would be the natural log of 2x minus 1. I'm going to keep that in parentheses so there's no confusion that I need the natural log of that whole quantity, plus natural log of x plus 3 minus, and then I would need the natural log of 5x plus 2 cubed, except I should recognize that that 3, the power drops in front, and I would get this. All right, and then life in calculus will be so much better when you take a nasty looking thing like this and write it this way instead. Now, here's a common mistake. Students will often have the natural log of a sum, and they will try to distribute the natural log through, and it doesn't work that way. All right, so in a few minutes, we're going to be looking at common mistakes with the laws of logs and what is and is not one of our rules. And if we look up here, oh, wait, back to slide 1, we should notice there is no law that says log of x plus y, right? There is no way to take this expression and simplify it, okay? So it's nada. All right, nothing we can do with this. If we get the log of a sum, we just have to leave it, okay? There's no simplification for it. So anyway, please pause the video and try letter B. And if you can do the problem in letter B, you've got it. You've got mastery of this. Okay, so pause the video and give it a try. First, take the natural log of both sides. Okay, so this is the answer you should have, and it would not surprise me at all if you did not correctly put this set of parentheses there, because the denominator gets written as, ooh, I'm sorry, I have a mistake right here. That at the moment, that should be a plus, okay? I jumped one step ahead and distributed the negative. So right now that should actually be a plus sign because this is a product, right? So I would add the two expressions. Let's see, drop the 10 in front. That's to the third, so 1/3 in front. But you have to subtract that entire quantity. Okay, so if I didn't have these parentheses here, then I would have been correct to have the minus sign. This negative would have to distribute through. Okay, but this would be the final answer. Okay, but I hope people understand why I need the parentheses, right? Because I have to subtract that quantity, right? This entire quantity gets subtracted. So moving on below, let's look at when I have correctly or incorrectly applied the law of logs. Okay, so please compare these three expressions to slide 1 and determine which is correct and incorrect. Okay, so for this first expression, this is incorrect, this is false. This, all right, so this is not equals, but this would be equal to natural log of x over y. Okay, so I hope you can see the difference, right? The difference between natural log x divided by natural log y, and then the difference of natural log x over y. And this is what we just talked about when I went back to slide 1. This is false. Lots of people try to do this because first of all, if you compare these two expressions, your instincts probably like this one here better, right? Your instincts probably say, I should be allowed to do this and not allowed to do what's in the line below, okay? But there is, because of natural log doesn't distribute the way that like a variable like y, right? If I had y times a plus b, right? Then I would get y times a plus y times b, and this wouldn't work, right? If I had ya plus yb, that would not work. But natural log is a special entity and has some different properties. Okay, so I know this one probably is not sitting well with your intuition right now. All right, and again, this is a very easy mistake to make. So moving on with some more exercises. Another thing that students will do incorrectly is they'll apply the power rule incorrectly. Okay, so look at these two expressions and notice the difference. All right, this is natural log x to the 5th. This is the quantity natural log of x raised to the 5th. Okay, so which of these is the correct application of the law? And I hope you identified this one. That would be correct. This would be incorrect. Now, number 7. Couple things that students do wrong in number 7. So we'll work our way to the correct answer by looking at what not to do. One of the worst mistakes that students make is they say, oh, can't the natural logs cancel? Right? Can't I just cancel ln? Right? You're thinking of this as like a variable L, a variable N times the number 16, right? If that were the case, then sure, they would divide to 1. But no, natural log, it's natural log of 16, right? This would be like the equivalent of saying that f of x divided by g of x is, what am I trying? No, that's not a good example. Never mind, scratch that thought. Trying to come up with some other similar example to kind of show you why that's ridiculous to try to cancel the natural logs. But anyway, like I said, that's the worst thing you can try to do is say the answer is 8 and try to say these cancel. That's not at all how natural logs work. The other thing that's a very common mistake is trying to say, oh, well, can't we just divide the 16 and the 2, right, and get natural log of 8? And then natural log of 8 is equivalent, since 8 is 2 cubed. Natural log of 8 is 3 natural log of 2. If you try to do that, then you are trying to apply what we said was incorrect here. Okay, so anyone who thinks that's natural log of 8, come back and, actually that's not exactly the same thing as this incorrect thing. But again, natural log of 8 is not correct. We can't just divide these two, okay? And so that would be like trying to say that the natural log of, let me try this again. This is also not true. This does not equal the natural log of x over y. All right, that's what they were trying to do there in saying that that was 8. So anyway, what can we do then? Obviously, the answer's got to be 4 by process of elimination. But what this actually comes down to is the fact that 16 is 2 to the 4th. Okay, and then I write natural log 2 in the denominator. That can simplify to 4 natural log 2 when I apply the power rule. And then natural log 2 divided by natural log 2, this does divide to 1 and leaves me with just an answer of 4. Okay, so one more thing that we've got to do today. All right, we've got to convert, because you're going to find in calculus that it's much nicer to work with natural log than it is log, right, to any base. Okay, so what if I decided that I want to change this in terms of natural log, okay, because I like natural log better. All right, and it is better. It's easier to work with. So anyway, if that were the case, I would take this and write this as 3. Base is 3. The answer is the exponent. And that would equal x. Okay, so what I would do in this case is take the natural log of both sides. Okay, so that's allowed. We've already said that's a legal move that I can do. So take the natural log of both sides, and I would get natural log 3 to the y equals natural log x. Okay, the reason this helps me, because I want to solve for y, right? I want something in terms of y equals, because that's the normal way to write functions in terms of y equals. But look what happens because of the laws of natural log, that y drops in front. So I get y times natural log of 3. Oh, messy. Natural log of 3 equals natural log x. Now I can solve for y. So y equals natural log of 3, I'm sorry, natural log of x over natural log of 3. All right, so you try to do something similar down here. Okay, if I were to write this as an exponential equation, take the log of both sides. Okay, so pause the video and try that. Okay, so again, taking the natural log of both sides, the y drops in front, okay, and then I have natural log of x here. The y drops in front, I get here, I can divide both sides by, oh gosh, I have another typo, or 7. So gee, we should notice something here, like a generalization. Okay, so if I want to take any log equation and change it to natural log, and no matter what my base is, so call the base A, for any base, I can write this. So let's go like this. So a generalization, log to the base A of x is equal to natural log of x over natural log of a. All right, so that's how I can convert any log equation to a natural log equation.